Like most hoppers, the main launch of my hopper takes place here at t=0. However, there's certainly lots that needs to happen in the minutes and hours before and after that launch in order to have a successful run that meets my design goals. Firstly, the production of ice needs to occur to have the custom-shaped piece of ice required by my ice timer. Producing that has been sort of an evolutionary process, but it actually turned out to be fairly easy. So I created this 3D printed mold here with a custom shape inside, and this worked far better than I expected. It might be worth having a seam line in that just to make the process a little bit easier, but ultimately this is probably good enough. Maybe print another. It's a low lead time component. It's not something that concerns me. Far more interesting and more concerning is the production of the hydrogen itself. Producing hydrogen has been an evolutionary experience, and there's lots of prototypes. The first of which involved some closely interleaved plates, which produced mixed hydrogen and oxygen and created some impressive results like the charring from explosions on this tube. The second one tried to separate it a little more to look at the bubble patterns using this hardboard. Unfortunately, the hardboard began to dissolve in the water, which was a big issue. So the third prototype has used these stainless steel washers separated by a 3D printed part, which precisely cants them outward and keeps them at the right spacing, and this has been much more successful. Using this, I've also been able to add in a piece of equipment to separate out the hydrogen and try and get just the hydrogen in one stream. In this configuration, the device is able to process about 2 amps of current continuously, which is almost, but not quite enough for the production rates I need. And then just for demonstrations, we can store it in this balloon. As shown in this video, we definitely are getting pure hydrogen, or at least close enough for our purposes. Of course, to up the production volumes even further, a fourth prototype is necessary, and that's the one that's going to use a plate material like this, which should give us almost 10 times more area, which both decreases the power requirements of the process and also increases the efficiency as well as the rates of production. So this is going to be happening soon, and that should get significantly more production rates and make the whole process a lot more manageable. Of course, once we have the hydrogen produced, it's time to store it. Storage was until recently something I didn't even know was possible, but this prototype has actually proven to be far more than I expected it to. This is a vacuum bag with a 3D printed valve connection to connect to the hosing that I've standardized on. This is really important because the hydrogen can be stored at 0 pressure, which is good to really decrease leakage. I thought this was going to be just a prototype, but it's so good, I think I might just assemble one with a little bit higher production quality and use that as the final one, which is really exciting to have that working. Also, I created this pump to transfer the hydrogen into the balloon that ends up being completely useless and unnecessary because it showed me that you can just squeeze the bag out and accomplish the same purpose. Of course, all of these components need to be combined together into the final hop, and that's what this device here is for. This is the main hopper. I refer to it as the gondola and the blimp. The gondola itself includes the ice timer, which you could just barely see moving in there. All in all, this is performing surprisingly well. If I needed to, I could probably use it as is. In practice, the timing is about 2 minutes instead of the 1 minute I was shooting for. So all in all, these components are all really working together effectively. It has very much been a process of iteration, but I can say without a doubt, launch is going to be exciting.